see how that worked. We were both practicing with CW, and I remember at the time that we made a call out there, and then somebody had the audacity to call back, and then we didn't know what to do. But we've improved our CW skills since then. But Andrew uses a mag loop antenna. He is in an apartment. That's where you primarily bought that for, right? Because you needed.
I live on a city lot in Tulsa. I have a high, like S9 noise level with all the LED light and whatnot in the city, and that actually can cut through a lot of the noise on CW. It's not much good on voice.
Right. So what I'd like to do is introduce Andrew to come up, and that's W5AWS, and he can tell us a little bit about his mag loop. And Mark, KD5SMF. There we go.
Yeah.
He actually has been trying to build a mag loop, and then he realized that it can be expensive. So, Andrew, if you'd like to show us what you've done,
Okay.
we'd appreciate that.
This is a mag loop. I have several mag loops, but this one is by Chameleon, and I got it on sale. So they're usually quite expensive, but this one was on sale one time, so I jumped on it. And currently it's configured for 80 meters. It'll do 80 through 10 meters, and there's a switch here, and you put a double loop on to get down to 80 meters. When I first got it, we were having the club was having an event a couple of years ago. I think it was Route 66 on the air, and I had this thing running, and I was listening, and I heard somebody calling on 80 meters for Route 66 on the air, and actually I replied on voice because I had one of those. True SDX receivers that was. I had one that was configured for 80 meters. So I just got it, and it has a microphone built into it, and there's a push to talk on the outside of the thing. So I pushed to talk, and I called back to the. It was N5D. They were calling W5AWS, but it was David Kennedy N5DMK, and I was able to make a contact with him. And he told me that yes, he heard me, but he thought I was off frequency, which was entirely possible with the rig I was using. But the interesting thing is, this was on 80 meters, which he was calling on. So you think, wow, that's pretty impressive. 80 meters on this thing with a 5-watt transceiver. Turns out David lives about a mile away. And I think the antenna was pointed in the right direction because these things are bidirectional. So the radiation pattern is in the plane of the loop. So it goes out like that. So the nulls are in this direction. So if you've got noise off to one side, you can null out the noise, but they're directional. They're not omnidirectional. They're bidirectional. So one of the real hassles with these things is that you go near them, it detunes them because they inside. This is these coaxes are actually shorted together between the shield and the internal core, and even though you're running 5 watts, you can have a very high voltage developing in the capacitor in here, as Mark's discovered. If you put too much power into the things, you can get arcing. If you've got one of those air variable capacitors, you get arcing across the plates. And some, I think, Precise RF, that guy produces full power, like 1500 watt mag loops, and he's got these vacuum capacitors in there that are motor controlled. Well, these things usually have a reduction gear on this air variable that's in here to adjust it, and when you put your hand near it, it detunes the loop, so the peak is very. It looks like when you tune it to resonance, it looks like this. And so the bandwidth, on 80 meters, the bandwidth will be very narrow indeed. And so the other problem is when you tune to another, when you QSY to another frequency, you have to retune. If you go too far away, you have to retune it, which is a problem. So you're listening, if you do it old school way, you're listening to the radio, and then you're adjusting this thing until you hear it peak the noise in the radio, and then you're kind of close. But what I do is I use a rig expert, and I can set this thing up and I can adjust it and watch the SWR come in. If you have a high SWR, you shoot RF energy into the antenna, it could come back and blow out the finals on semiconductors. If you're running vacuum tubes, it doesn't really care too much about it. But what I did was I got a motor so I can remote tune the antenna with this remote control unit. So there's a motor on here and it's just attached to that. And then this is a and that's
your VNA?
This is a VNA, yeah. And this is tuned to, right now it's tuned to 3.565, which is on. So you can use this, use your VNA, and what you can do is you can set the marker to a frequency. Let's move it up a bit. Oops, let's get out of there. You can move the marker and then you can use switch this thing on, jog it up. Can you see it moving?
Let me zoom in there a little bit.
So you're telling us that the motor is moving inside of that box?
Yes.
Get the
capacitor?
reflection down a little bit, turn it this way.
Like that way?
Yeah, there you go, that's better. Now go ahead.
Do you see it?
Mm-hmm. You can see it moving.
So when you have your VNA, it makes the tuning of the antenna a lot easier, because you can set it up and then tune it with a remote control. You can see it on your VNA, which makes it more accurate. But the thing to consider about the VNA, this display is represented by 101 samples from one side to the other. You then start to discover about Nyquist's theorem of if you're doing digital stuff, the sample rate. If you're trying to digitize an analog signal, you need a sample rate that's at least 10 times greater of a minimum above the frequency you're trying to digitize. Well, when you've only got 101 dots across here, you can be missing some of the null points on here. You can change the number of dots on the VNA. I think it can go up to 400 dots, but the problem is it then takes a long time to scan, to refresh across the screen. And if you're moving the tuning, the VNA can't keep up with the tuning rate. So it runs a lot faster at the default of 101 dots on here. And you can see that with the if you have a bandwidth of, say, 100K, and you're representing this 100K from here to here, but with 101 dots. You've got, say, 100 dots across here, and there's a 1K between each one of these dots. So if you've got a tuning point that's between one of these things, you're not going to see it on this display. So what you can do is, if you're, I have the VNA tuned to, I have it calibrated for the 80-meter band, and that is the start frequency is 3.5 meg, and the stop frequency is 4 meg. So there's 500 kilohertz from this side to that side. So if I wanted to get more accuracy, I can change the display. So instead of 101 dots, I can go up to 400 and get more accuracy on here.
So Andrew, how high does that have to be in the air to be able to use it?
That's a good question. They do say that it needs to be about a meter off the ground, because when you've got it too close to the ground, it would detune as well. And I did see a video of a guy, a Canadian operator. He had a loop, and you'll notice that the loop is not perfectly round. He said on his experience he'd had better results when it was more egg-shaped, and you can move this stuff around and then look at the VNA to see what the best results you get. So as you can see, there's a lot of, it can be quite fiddly, but once you get the hang of it, it can be relatively simple. And on this particular VNA, let's see, calibration. I have 6 storage locations here. I've got 80 meters, 40 meters, 30 meters, 20 meters. I think that's what's 17 meters, 21 and 10 meg, 10 meters. So I've got the various calibrations on here. So if I wanted to change to a different band, I could just recall the appropriate band calibration for this VNA, and then I can do what I'm doing here on 80 meters. And on this thing, on the low band, it will do 80 through 40, and then on the high band, it will do 40 through 10. And then to do 40 through 10, you just take one of these loops out and flip the switch, and then you're then operating to 40 through 10. It does not. There's a larger induction loop and another cable to do 60 meters if you want to do that. But I never operate on 60 meters.
Mark, you were doing some development work on this.
Yeah.
What's your experience in trying to make a mag loop?
Well, let me get in front of the camera here in just a second.
Did you have any questions here?
Yeah. Have you done a comparison of the performance using it indoors versus outdoors?
You get better performance outdoors than you do indoors, but mainly I operate I'm usually a portable operator. I go away from my house because of the noise levels there are just unbelievable. But I have operated the mag loop from inside the house, and I've done PSK 31, and I've had good success with that from inside the house. So yes, it'll work better outside, away from and the other thing is you don't want to put a lot of power in here because there's high voltage, and if you were running some of these higher powered loops, you want to be standing well away from it, because of the energy coming off it.
Exactly. Well, what I found in my research, what I was doing is I'm researching different antennas. Like everybody who starts out in this hobby, you start with a dipole antenna, you make that, you have excellent results. Then you may want to go to something like a vertical antenna. You learn how to make one of those, and then you have really good results. with that, and then you move up to maybe an end-fed half wave. I started out with most of these going end-fed half wave, and end-fed half wave developed into the delta loop, and then with the delta loop I have a sky loop that I made in my backyard. So I'm mostly all HF. But the problem is that when you want to do portable operations, you need something that is compact that you want to do, and this antenna fits the bill. And I told my wife that I can make a antenna like this, and I actually have fabricated the loop here and assorted parts. I went to Chameleon on their website and I bought one of these loops right here. The only parts I don't have to complete that project right now is a suitable mast here and the capacitor. The biggest problem that anyone who wants to make one is finding a suitable capacitor. In my research, what I found is that a dual gain air variable capacitor does not detune like if you have the tuning knob right here. I bought a 6-to-1 gear reduction drive for a 1/4 inch shaft, and I bought 2 of those, and I had it set up. By the time I actually got all my parts together, the part that I needed the most was the dual gain capacitor. And when it finally arrived from wherever place in Asia where it came from, it was tiny. The guy had blown up the pictures on eBay. The capacitance was the right capacitance that I needed, but one of the gangs is smaller than the other gang. And so, this is not going to work out, even though it would fit inside my box with that. But you have to have you have to have your shaft perpendicular to all the other components. So if it's at an angle or something like that, it's going to throw things off. So you don't want to do that. You want to have. So I ordered a different box, and I've got parts for this project. But I'm not going to be able to finish it because I cannot find a suitable air variable capacitor. And during Hamfest, I did see several that would probably fit the bill, but not having a capacitance tester in my back pocket. I have a portable one I could have brought with me, but I was thinking in my head, you know what, I've got this one ordered already, I'll wait for it to arrive. Long story short, you can go and buy this unit and get on the air. I could get on the air with just buying this unit right here. It's around $350 to $350 just for this bottom unit with the motor. So when you have a budget that is, I've actually exceeded my budget way out.
Amen.
So I could have actually bought this entire setup, even though it is closer to $600 right now. Well, DX Engineering is one of the sites I go look at, and so I hate to say that I'm not going to, may not actually finish that project. It is just kind of shelved right now until I can actually find a suitable capacitor. And there's other places on the internet that you can actually find better capacitors. RFparts.com is one that I actually have found where they have some actual good quality capacitors, and what you're looking for are capacitors that have the width between the blades. You need extra width. If they're too narrow, you run the danger of arcing out with higher power. Now there are guys who have built these loops that can handle 100-watt output, and they're monsters. They have monster capacitors. So that kind of defeats the purpose if you're going to have a portable unit. So
I do have a suggestion that
yeah.
you might want to try. Instead of having a variable capacitor, you could try a fixed disc ceramic high voltage capacitor, and then as you to change frequency, you have them pluggable, make pluggable modules, so that you could. So if you have some, and you would need to run the numbers on the calculators to find out what kind of capacitance you need and the voltage, and then you can go and buy the disc ceramics and have them on a pluggable module that can go onto your unit.
No, I never even thought of that, you know, so.
I mean, the antenna has all sorts of neat benefits.
Yes, it does.
It's got a high Q, so it's almost like using a Yagi or something that is a beam, because you're going right off the sides. And we know that it can cost some money. Do we have any other questions from the audience that these guys can answer for us as we are wrapping up this presentation?
Mark, when it comes to Zapcasol?
None.
None?
I haven't had a chance to even get it on the air yet. Okay, basically I'm trying to use it with my FT817, which is a 5-watt little rig, you know, QRP rig. And do POTA or something like that with it. So the other options, of course, for POTA are vertical antennas or an infed, or I built a dipole that's specifically made for 20 meters. Something that's easy to throw up in a tree and just get on the air quick. And that's usually what POTA is all about.
All right, gentlemen, I want to thank you so much for sharing your experience with us in the matter.
All right, field day in 700 parcels. Same gist we have every year. We do this same concept, everything's going on. Here's our focus real fast for tonight. I'm going to try to expedite as much of this because a lot of it's kind of some repeats, but anybody new here that has never been to field day, has no idea what field day is? Okay, perfect, awesome.
Is this going to be on the website, by the way?
Yeah, so this will be posted later tonight, so if you want to look at this and download it, you can, just like the one from last time. But field day is what it says here. It's a picnic, it's camp out, it's practice for emergencies, informal contest, but really it's all about having fun. It is our open house, if you will. It's where amateur operators across the globe get on to have fun, talk, make points, and just go to town. So if you want to experiment, if you want to make stuff, this is a great time to do it. But it's also time for us to bring the public involved, bring your friends, bring those that are on the fence about becoming operators, come on out and try stuff, because there are typically a lot of operators on site that you can